For the final lesson this week, if what I'd start to do for sort of the 4 lessons each week, or for 4th lesson each week, is pick out some topics that we've covered before and just set a range of questions, revising those. It's up to you how you want to do this, whether you want to sort of do them all at once, whether you want to try and do one each day. I would maybe try and spread them out a little bit so you get that sort of spaced practice, so you can keep coming back to the topics and hopefully by the end of a week have revised them and know them really well. And of course, if you are struggling on any of them, do try and have a look for them, search for them on Hegarty Maths, practice those topics on there, and then come back to them. Don't just keep missing out questions because you don't know how to do them, or keep getting them wrong. I'll put the answers at the end of the week on Google Classroom. What I'm going to do here in this video is just go through the first set of questions. So if you aren't sure on any of the answers, you can check here, and hopefully the explanations here will help you to try some of the other questions. So the first topic is multiplying and dividing by powers of 10. So here we've got 2.65 multiplied by 10. What I'm going to do, if I'm multiplying by 10, that means I'm moving everything 1 decimal place to the left. So if I'm multiplying, I'm going to the left, or multiplying by 10 at least, I'm going 1 place to the left. So this 2 is 2 units. That's going to become 2 tens. My 6 tenths is going to become 6 ones. And my 500ths is moving 1 place over to become 5 tenths. So that would be 26.5. I do 2.65 multiplied by 1,000. Well, this time I'm moving 1, 2, 3 places. So the amount of zeros can give us an indication of how many places we're moving over. I'm moving 3 places to the left. Again, to the left because I'm multiplying. So multiplying by 1,000 is going to make my number bigger, is going to move the digits over to the left. So that 2 is 2 ones. If I multiply that by 1,000, it's going to move 3 places. So from 2 ones to 2 tens, 2 hundreds, 2 thousands. So that's now in the thousands column. That's 6 tenths, moving 3 places. It's going to go to 6 ones, 6 tens, 6 hundreds. So that's 600, that's 5 hundredths, 5 tenths, 5 ones, 5 tens. So it's going to move to 5 tens, and then I've got nothing left in the ones column. So my answer there is 2,650. Once I've got that first digit in place, actually the others are quite easy to do because they move alongside that. My last one, now I'm dividing, so I'm going to be moving to the right instead. Dividing by 10 is 1 0, so I'm moving 1 place to the right. So instead of having 2 ones, I'm not going to have any ones. That 2 is going to move to the tenths. That 6 tenths moves 1 place to the right to 6 hundredths, and that 5 hundredths moves 1 place to the right to be 5 thousandths. If you're getting quite confused with the terminology I'm using here, hundredths, thousandths, tenths, then do practice the place value tasks and have a look at those on Hegarty Maths. Okay, the second topic is written multiplication methods. So what I'm going to try and do here is show you just one of the methods for written multiplication. I'm going to use the grid method because it is my favourite method to use. So the downside of using the grid method is that sometimes people get confused over the amount of zeros that they're writing, but I think it's a lot easier to see what each of the individual steps are, and it's a lot easier to extend it. It works really well for expanding brackets in algebra, and when we come to factorising, anything like that. So it does have a lot more scope, I think, than the other methods. Where there's just a lot of steps to remember. So because I'm doing 26 times 156, I've got a 2-digit number multiplied by a 3-digit number. So what I need to do is I need to do a 2 by 3 grid. So there's my 2 by 3 grid. And I've got 27 being multiplied by 156. Okay, so I'm just splitting what we call partitioning these numbers up. 27 is 20 plus 7. 156 is 100 plus 50 plus 6. Okay, I don't actually need to partition these in these way. I could have partitioned 27 as 25 and 2, but for multiplying it's a lot easier if we've got things that have zeros in them at the end. Because now 100 times 20, I can do 100 times 2 would be 200, so 100 times 20 would be 2000. 50 times 20, 50 times 2 would be 100, so 50 times 20 is 1000. 6 times 20, 6 times 2 is 120. Sorry, give me the answer way there. 6 times 2 is 12, so 6 times 20 is 120. Okay, because when I'm multiplying by that extra 10, it's moving everything one digit to the left. I don't want you to think about it as adding a 0 on, it's moving things over one digit to the left, like we did here. Essentially what I'm doing is instead of multiplying by 20, I'm splitting that up into multiplying by 2 and then multiplying by 10, because altogether that's multiplying by 20. Okay, on the bottom row, we've got 100 times 7 is 700. 50 times 7, so 5 times 7 is 35, so 50 times 7 is 350, and then 6 times 7 is 42. And now I need to add these together. So we've got 2000, and what I'm going to do is just write them in a column. I'm going to tick them as I write them, so that it's a little bit easier. 1000, so I don't miss anything off. I'm also going to try and write them in size order. I don't have to, it doesn't matter if I don't, it just sometimes helps us keep track of the numbers we're adding. So 700, 350, 120, and 42. Now my units just has that 2 in. My tens, I've got 5 plus 2 is 7, plus 4 is 11 tens, so that'd be 110. So I've got can change that into 110 and 100, so 110 is 100, so that's why I've put 1 in my hundreds column there, and 110 there. And I've got 700s plus 300s, so that's 10 hundreds, 11 hundreds, 12 hundreds, so let's change that into 200s and 1000. 2000s plus 2000s plus 1000 is 3000s, plus another 1000 is 4000. So 27 times 156 is 4,212. Okay, of course, there are other methods for doing that. That is my preferred method, but you might have your own. If you get the right answer, that's absolutely fine. If you don't, maybe try this one. Okay, the next task is ordering decimals. So to order decimals, what can actually really help is writing them in a column. So 0.5, 0.4, and what we need to make sure we do here, I'm just going to tick them off as I write them. 0.54 is we keep the decimal point lined up, okay, because I want, these are all what's saying I've got 0 ones, I've got 5 tenths, 4 tenths, 5 tenths, they need to be written in that column. Okay, 0.05, so I have 0, decimal point still coming there, 0.5, and 0.451. Okay, and the reason why that helps me ordering them is because I can look down one column at a time. That first column, they've all got no ones, so that doesn't tell me which is bigger, which is smaller, they're all less than 1. On the next column, well, this one has 5 tenths, or 5 0.1s, it has 4 tenths. Which has the fewest amount of tenths? It's this one here. So 0.05 must be the smallest, because it's got no tenths. All the others have some tenths. Well, this has 5 tenths, this has 4 tenths, so it must be smaller. 5 tenths, so it's bigger than this. So there's these two numbers that have 4/10. Okay, which one's smaller out of those? Well, if I look in this next column, my hundredths, this has 5/100ths. This doesn't have anything written, so it has no hundredths. So 0.4 must be smaller because it has 4/10 but no hundredths. This has 4/10 and 5/100ths as well. So that's my next number, 0.451. Okay, it has to be smaller than these two because these have more tenths. Okay, and these both have 5/10, so that doesn't tell me which is smaller. I look at the next column along. This has no hundredths. This has 4/100ths, so this must be smaller. So I get 0.5 and then 0.54, and that's how I order my decimals. Okay, skill number 4, finding fractions of amounts. So I'm looking to find 3/5 of 30. The way that I do this is I look at the denominator first of all. So I think, well, what would 1/5 of 30 be? So I've got 30 and I want to basically split it into 5 parts. If I draw this like a bar model, I'd have 5 boxes and I'd want 3 of them. And I'm saying that whole thing is 30. I want to find 3 out of 5 parts. So the first thing I do is find out what one part is. I do that by taking my 30 and dividing it by 5, sharing it between those 5 parts, so each part is worth 6. So 1/5 of 30 is 30 divided by 5, which is 6. So 3/5 of 30. Well, I'd take my 6 and I'd say, how many lots of 6 have I got? I've got 3 lots of 6 because I want 3 of those fifths. So that gives me 18. That's how I'm finding fractions of amounts. To collect like terms, so we're looking for lots of the same thing here. The way I'd read this out, this is 2 lots of x. Let's put a box around that. 5 lots of y. They're not lots of the same thing, that's why I've used a different symbol. Okay, because that's lots of x, that's lots of y. Minus 1, so if we don't see that as being 1 lot, we can just put a 1 in front of it. So it's minus 1 lot of x. If we don't have a number written there, it's because we have 1 lot of that thing. Well, I've had lots of x there, so this is another lot of x. So I'll put another box around that. 2 lots of y, it's another lot of y. So I can put a circle around that, and then I'm collecting the things that have the same symbols. 2x minus 1x just gives me 1x to end up with. 5y plus 2y is 7y. Okay, you notice when I put these boxes round, I was always including the symbol, the addition or subtraction symbol before, so that I can make sure I don't make any mistakes with adding something on when I should be subtracting it. Okay, let's do the same with this bottom one. So I've got 3 lots of x squared plus 1 lot of x. Now, these both have x's in. I've used a different symbol because they are lots of different things. This is 3 lots of x squared. That's 1 lot of x. It's not the same. It's using the same letter, but here I've got x multiplied by itself. Here I've just got x on its own. They're not lots of the same thing, so we can't combine them if we're adding and subtracting. If we were multiplying, we could combine them and we'd change the power. It's not what we're doing here. Okay, now minus 5, well, that's just a number on its own, so it's not a lot of x, it's not a lot of x squared, so I need another symbol for that. Let's use a triangle. 2 lots of x, we've had lots of x already, they're my circles. Notice again how I'm using the same symbols for each type. So circles here, minus 5, so just numbers on its own, plus 3. Essentially that's minus 5 lots of 1 and plus 3 lots of 1. And I'm also including the signs in each part. 3x squared, okay, I've got another lot of x squared here. So I can put a box around that, making sure I include my minus. I start off with 3x squared. What other boxes have I got? I've got a rectangle here. So 3x squared minus 1 lot of x squared. It's just 1 lot of x squared because there's no number written in front. So that gives me 2 lots of x squared. X plus 2x gives me 3x, minus 5 plus 3 gives me minus 2. And I've collected my like terms there. I can't collect them any further because each term, each thing that I'm adding or subtracting, is a lot of a different thing. Okay, the final skill, finding areas of triangles. Okay, we might, hopefully, can remember our formula that the area of a triangle is half multiplied by the base multiplied by the perpendicular height. Okay, so half the base times the perpendicular height. And the reason I say perpendicular is, although this right angle isn't drawn on here, the two lengths that we're multiplying need to be at right angles from one another. So one of the things we need to consider in our triangle is what our base is. So here I'm going to choose this as my base. So it's half times 4. And then I need the perpendicular height. So the height of a triangle that's at right angles to this base, which is this 3 going up here. Okay, so I don't end up using that 5. That's not my perpendicular height. This is my perpendicular height here. So a half times 4 times 3 would give me 6. My units would be 6 centimeters squared. Okay, it's centimeters squared because it's an area, because I've had one length of centimeters multiplied by another length of centimeters. Okay, so similar to how we'd get x squared by doing x times x, we get centimeters squared by doing centimeters multiplied by centimeters. You might get some triangles here where things are turned around. So actually you're like, if to use this 5, I just turn this round here. If I had 5 as my base instead, then what I would have needed was this perpendicular height going up here, and I could have then used those two lengths. Okay, so it's not always using two of the edges of the triangle. It depends on what information that we're given. Okay, so try the other pages for that. See how you get on. Again, I'll put answers up at the end of the week. And hopefully doing this each week will make sure we don't forget some of the things that we've practiced before.